All right, good afternoon. I'm going to go over the last 3 smart boards, so Thursday, Friday, and today's lesson. So tangent line was Thursday, chords and arcs were Friday, and today was angle measures. So those are the 3 things I'm going to be going over. I'm going over verbatim what was in the smart book notebook, so maybe you can look back at your notes. So we're going to start with tangent lines. These notes were on the back of your vocab sheet that you got on a week ago on Monday. Yeah. I don't have any extras, so I can't show you. So the first thing, tangent lines, there was only three things you should have learned. First thing you need to know is that tangent means that it only touches the circle one time. And that point is called the point of tangency. Okay, so the first theorem that we learned was that if a line is tangent to a circle, then it is perpendicular to the radius. So the key thing you need to know is that the radius and a tangent line make 90-degree angles. Only a radius with a tangent line. So later on you're going to see an example that maybe, I'm trying to think of what it might look like. Like that. Is that going to be a 90-degree angle? Well, no, because the radius is right here. So it has to hit the center. Okay? So some examples right here. I'm telling you AB is tangent. So I'm going to draw the 90-degree angle because if it's tangent, I know it's 90 degrees with the radius. I know that's the radius because it says circle C. So that means it's the center. If AC is 25, find the radius. So the first thing I keep telling my students is, with circles, when in doubt, you're still going to need to find a triangle. Now with circles, you're also going to want to find a radius if you can. So CB is my radius. So how do I find that? Well, I can just do Pythagorean theorem. And then I want to get R by itself. Minus 225 on both sides. And actually, if you know your rules, this is actually a 3, 4, 5 triangle. So my radius is 20. Now, I told you to find a radius, so we can just put 20. On your quiz, you might get a question like, let's call this X. What is AX equal? Well, remember, always find a radius. There's a radius, but so is right here. So if this is 20 and this is 20, what is that point right there? So we get 5 because 25 minus 20 equals 5. So you may be expected to do something like that. All right. Also, if I were to tell you that these were tangent, find the value of x. Well, since I know ML is tangent and it's circle O, that's the radius, I can put 90, and that's also a radius. Now, what is this whole thing here? It's a 4-sided figure, so it's a quadrilateral. So what do they all need to add up to? 360. Well, 90 plus 117 plus 90 plus x. Add them all together, subtract from 360. And you get 63 as x. So that one's just knowing about your quadrilateral rules. Last one on this topic would be, can you assume? Of course not. So how do I know if it's tangent and only touches once? Well, I have to see if it's a right angle. How do I know if something's a right angle? Well, then C squared would have to equal A squared plus B squared. So my C would be 52 because that's the biggest number. And if I did the math, 52 squared is 2,704. And 20 squared plus 42, nope, 44, I wrote that weird. squared is 2,336. Are they equal? No. So AB is not tangent. Okay. Here's an example that will be probably on your test or quiz. And right here, the best thing to do in this case is it wants to know from this center to this center the distance. Well, this is a trapezoid maybe. I mean, I don't know anything other than it's a quadrilateral, but I can totally create a rectangle. And now I have just created a 90 and a 90. So then if this is 8, this is 8. If this is 35, then this is 35. Well, how does that help me get my two centers? Right here. I have also just created a right angle. Now, I already know that's 35. How do I find this little piece? Well, if the whole thing's 14 and that's 8, then we have 6. How do I find x? That's the hypotenuse. So c squared equals 6 squared plus 35 squared.
Question.
So then, sorry, interruptions, my bad. This is 1225. Add it to 36. And I'm going to be lazy right now and say this is your answer. So the distance between the two. And the square root of 1,261 is 35.5. Okay. That'll be a tricky one. Alright, the next theorem is that if you have two tangents, they are congruent. That one should just be super basic. They're the same. So right here I have two tangents. They intersect, so these are the same. Alright, up here it tells me that this whole thing is 7. This whole thing is 9. And this whole thing is 8. So if it's 9, there's 5, that's going to be 4. Well, these are two tangents, so they're going to be the same. It's 7 and 4, then that's 3. Here, 2 more tangents. Those will be the same. And then right here, 5, that's 8, so that has to be 3. And so those will be the same. And then just answering those questions. FE is 5, JC is 6, and the perimeter is 30. And then the last theorem is that if you have those two tangents that intersect, if you connect the center to where they intersect, it bisects it. So those will be the congruent. So right here it tells me that C, the radius of C is 39. Well, I have a radius right here that could be 39 and a radius right here. They want to know AB. Well, if AD is, oh, and these are tangent. You have to know those are tangent. So I also know that's 90. I'm telling you they're tangent. So if this is 80, then this also has to be 80. CB, we figured out was 39. ABC is 90 degrees because it's tangent. And then AC, here's the hardest one to get, but maybe not that difficult. Is, remember, when in doubt, what do you have? A triangle. So I'm going to call this X, and I can do Pythagorean theorem. Now that's across from my right angle, so it's going to be X squared equals 80 squared plus 39 squared. That's going to give me 7,921. Which gives me 89. And then they want to know what DAB is. Well, DAB is this whole thing, but I can't just find that easy, but I can find this one by doing what? SOHCAHTOA. I have opposite and adjacent. And really you could use the hypotenuse, but that's the tangent is opposite over adjacent. Make sure your calculator is in degrees. And if I need to find the angle, I'm going to do inverse tan. So that gives me 26.0 degrees. Now, that's just DAC. I want the whole thing, so what am I going to need to do? Times 2, and you get 52.0 degrees. So there you go. This will probably be a test question. That's all about tangents. Now we're going to move to chords. So chords are a little bit different. Some things you need to know about chords, and I'm going to only do probably two example problems on here. They're kind of big kahuna example problems. Okay, 3 example problems. So the things you need to know about chords is chords are congruent arcs. So you see how they're both 150? Then that tells me these two are congruent. Okay. What you also need to know is they're both equidistant from the center. So if that's my center, they're the same distance. And last but not least, this one to me is the most important. That if it's perpendicular, your radius and some chord is perpendicular, then your chord is bisected and your arc is bisected. Okay? And vice versa. If they're bisected, then your chord is perpendicular. So now I'm going to do, okay, I lied. I'm going to do probably 5 examples with you just to make sure y'all are good. Here is my first one. It tells you that TR bisects PI. So this is congruent to this because it bisects. If PI is 8, then it'll be 4 and 4. TN is 3. I want to know NR, and I want to know TP. So, NR is right here. That one's going to be a little bit more difficult. But TP, what do I have? Well, because they bisect, I know that this is perpendicular. So now that I have a right triangle, oh look, and I have 3 and 4, what is TP? TP is 5. Now I told you earlier, 2 things you need to do. Find a triangle and find your radii, your radius. There's a radius, but is there another one? TR is also a radius. So what does TR equal altogether? 5. So if that's 3, what's NR? 2. So just be aware this is not bisected. Only the chord is bisected, not the radius. However, it can be, but it's not. For this one, OL is perpendicular to CA. So because I know it's perpendicular, then I know it's bisected. OR, this should be connected, is 25. And OL is 7. They want to know what is CL and CA. Do I have a triangle here? Well, technically I could right here. And what's OA? It's also a radius, so that's also 25. And same thing over here. We could connect that one, no problem. Now, if 7, 25, what's this? You can do Pythagorean theorem. I'll call that X. But if you know your Pythagorean triples, you know that this is a special one, and x will be 24. So if LA is 24, what's CL? 24. So CL equals 24, sorry. And then what's CA? Add them together and you get 48. Okay? It's all about triangles. A little bit more complicated, sorry. For this one, I know that GB is 51 degrees, and I know that AB is congruent. Oh, that was a bad line, sorry. AB is congruent to CD. Okay? And I also know CD is 8. Well, there's a 90-degree angle here, so that tells me these are congruent. So if CD is 8, we have 4 and 4. And if they're congruent, then this is also 4 and 4. Okay? Now, what's AB? Now remember, if it's 90 degrees, this bisects, but so does my arc. This side is congruent to this side. And because these are congruent, this is congruent to this. So it'll be 51 degrees. So what's AB? 102. FD, we already found out, was 4. CD, so what's this whole thing going to be? Remember, the chords are congruent, so the arcs are. So that's 102. And AB would be 8. Also to note, this will be congruent to this. I don't have any distances, but just know that they would be congruent. Alright, for this one, it's a circle Z, so this is my center. The radius is 6. I don't have a radius. Oh, I do have a radius drawn. So this is 6. ZF is 3, so then that makes FH 3. And HG is 60. Alright. So what's the whole thing going to be? Well, it's 90 degrees, so this is congruent to this, so then this will be congruent here. So, and it's 120 degrees. They want to know what angle CZH is, so I'm going to connect CZH. And remember, that's a central angle. If my arc is 60, then my central angle is also 60. CF, oh, so if I put 60 here, that's 90. I'm going to redraw this right out here. We said this is 60 and this is 90. So that has to be 30. If I know this is 3, hey, what's this right here? That's a radius. What's my radius? 6. Remember, we can't go around the 30. Around the 90 is going to be 3 square roots of 3. So then what is FH? Oh, we already found that. 3. There you go. You're going to have to know your 30, 60, 90 rules. Around the 90 is times square root of 3. Alright, last one on chords. For this one, the diameter is HL, and that's 20. So that gives me 10 and 10. CL is 120. So if arc CL is 120, then so is my central angle, which makes this 60. DA is perpendicular to CH, so that tells me that this is congruent to this. And CH is congruent to HF. Well, what is HF? Well, if this central angle is 60, because they're a linear pair, then this is 60. And if they're congruent, then so are their arcs. So it's also 60. Angle CDA, well, CDA, if it's bisected, that means it's half. So 30 and 30. And if those are each 30, then that angle is also 30. All right, now it's going to get a little bit tricky because it's going to be small, my writing is. But I want to know what side BD is. I have a triangle here. I told you to form a triangle and then look for your what? Your radius. Well, my radius right here tells me this is 10. Do I see any other radii? There's 10, and then there's a 10. So we said this was 30. That's 90. So this is 60. Going around my 60. What is that going to be? 5. Going around my 90. That will be 5 square roots of 3. So that is my BD, 5 square roots of 3. Well, now it wants HF. Well, if I know CB is 5, then BH is also 5. So what is CH? 10, and if they're the same, so is HF. Last but not least, do you agree that AD is a radius? So it's 10. Do you agree we just said BD was 5 square roots of 3? So how do I find BA? I subtract. I can't actually subtract them. Well, I can like that, but I can't simplify that anymore. So it's just 10 minus 5 square roots of 3. All right, that's all there are for chords. Last but not least, what we learned today, we learned angle measures. So if it's not a central angle, then it's not an inscribed angle, it's just intersecting angles. If they intersect inside, you add the arc plus the arc and the angle in the middle, or divide by 2, and that gives you the angle in the middle. So these vertical angles will be the same. If it's outside of the circle, they intersect outside, then you're going to subtract. Now you want a positive number, so you're going to subtract the big minus the little and then divide by 2. And that'll give you that one. Notice these are the different ways that it could all outside. So sometimes it's going to be a big like this minus a little. Sometimes it'll be a bigger and the little like that. Or sometimes you're going to use the full circle because it's 2 tangents and it's the big minus the little. So here are some examples. My first example, first thing you want to notice is it's intersecting inside. So I'm going to use the x plus y divided by 2. Well, if AB is 46 degrees and DC is 90 degrees, I want to find J, so I'm going to add them together. So that gives me 136 divided by 2, which is 68 degrees. And now what do I know about J and K? They're a linear pair, so I just have to do 180 minus 68, and I get 112 degrees. For this one, arc AB is 80 degrees. Do you agree that the rest has to add up to 360? So arc ADB is 280 degrees. Because 360 minus 80. Now, for ABC, for this angle right here, it is on the circle. It is inscribed. So I can divide by 2, and I get 140 degrees. Same thing, for EAB, I can divide by 2, and I get 40. And just a little word, somebody asked me earlier, is this 90 degrees because it's a tangent? No, because it's not touching my center. If it was touching my center, that's 90, but not that. All right. 3 more examples. These are intersecting outside, so we're going to do x minus y divided by 2. It tells me AB is 95 degrees. CE is 55. And you always do the bigger minus the smaller divided by 2. That's going to give me 40 over 2, which is 20 degrees. So Z is 20 degrees. Okay. Right here, if ADC is 250 degrees, well, how do I find AC? It makes a whole circle, so that's going to be 110 degrees. It's intersecting outside, so it's x minus y divided by 2. So 250 minus 110 is 140 divided by 2 gives me 70. Last one. For this one, I have the outside, so it's intersecting outside, so I'm going to do x minus y divided by 2, but I already have the angle. So that's going to equal 40. I need to find my smaller one. So that's going to be 110 minus z divided by 2. And the smaller one has to go second, or else you'll get a negative number. Equals 40. Now we're just going to do some algebra. Times by 2. So 110 minus z equals 80. 80 plus z, subtract 80, and you get 30 equals z. Again, you could have done that a couple different ways. You could have subtracted 110 and then divided. It doesn't matter. So my z is 30 degrees. All right, if you have any questions, all the bookworks are in my Google Drive if you need to go to that. If you need the link, just send me a message on Remind. I do want to let you know one of the bookworks for tangents, it gives you a question that looks something, I'm going to make up some numbers, but 2x squared and 20x. Well, if those are equal to each other, isn't this technically 2x times x? Can I cancel out an x so that 2x equals 20? Oh, that's a weird equal sign. And then just divide by 2, so x equals 10. So that should help you with day 2 homework if you got confused. All right, y'all have a wonderful day. Thank you.